Hello everybody and welcome back to the channel. In today's video I'm going to show you how you can build your very own Pokedex using some of the new tools that were announced at WWDC 21. So that means we're going to use async and await for our network calls, and we're also going to use some new features like AsyncImage from SwiftUI 3. So if you look at my screen, right now I have a simulator running, and this is what we're going to go ahead and build. So you can see we get the name of Pokemon, its type, a little description, as well as an image of what it is. So in order to do that, we need to communicate with a backend, so like an API. So this is something you're going to find that you'll be doing a lot as an iOS developer, is communicating with some kind of backend service. So we need a backend or an API to give us the data that was now being shown in the app. So we're going to use this endpoint right here. It's this Pokedex-bb36f firebaseio.com/pokemon.json. And you want to put this in some kind of tool like PAW or Postman, or even online there are some like JSON viewer tools that you can use. And when you use that, you can actually send a response and you can see all the data that you're going to get back from that endpoint. So if we look over here and zoom in a little bit, you can see this is the response that we got. So we have at this first index, attack, defense, description, evolution chain, height, ID, image URL, name, type, weight, and then all of the information that was passed back. So this is what we're going to use in our model that we actually make to get different pieces of information about a Pokemon. So if you are ready, let's go ahead and get started. So in order to build this, you're going to need the beta version of Xcode. So it'll be Xcode 13. And if you watch this in the future, maybe it won't be beta anymore, but it'll be the actual version. But for right now, as I'm releasing this video, we're on beta software. So go ahead, open up a new project. You'll see app, hit next. And we'll just call this Pokedex. Make sure you have it as SwiftUI and language is Swift. Hit next. And we'll just save it to the desktop. And now you can see we get our new Xcode project. So let me update this to larger text so you can see a little easier. And here we go. We have our basic project. I'll resume the preview, make sure everything's working as we expect. Now that we see that's working, we got hello world. Now let's start building this out. So the first thing we're going to do is create our Pokemon model and the networking call so that we can actually get data back. So let's go over and hit Command N, and you'll see we have all these templates. So we're going to use a Swift file, hit next, and we're going to call this PokemonModel and hit create. I'm going to zoom back out. What we're going to do here, instead of foundation, we're going to do import Swift UI. And now we'll just start building this out. So let's call this a struct Pokemon. And since we're going to be presenting our Pokemon in a list, we need it to be identifiable. And since we're going to be getting this back from an API, we need it to also be decodable. So you can see here on the screen, it says a type that can decode itself from an external representation. That external representation, in this case, is our API. So we'll give it a unique identifier, let PokeID, we'll make that a UUID. So that's unique, it's able to be identified within the list that we'll create later. Now we'll just get back some of the properties we want. So we'll use ID, we'll get the name, we'll get the image URL, get the type, and we'll get a description. Now, I've introduced a new property that doesn't currently exist on the API. So what we need to do is we need to tell Xcode that we want the specific fields returned back from our network request. So the way we can do that is through something called coding keys. So we'll create an enum, it'll conform a type string, and type coding key. So you can see a type that can be used as a key for encoding and decoding. So when we use that, now we just specify the cases for the properties that we want to get back from our network call. So I'll use ID, name, and here I specified the image URL using all capitals, but if we look back over in my tool in PAW, you can see image URL they have is lowercase. So this needs to match exactly, otherwise your network call is going to fail. Or you can do what I'm doing and specify a specific coding key. Next, we'll have type, and finally, description. Okay, and that is our basic struct. So this is going to give us ID of the Pokemon, its name, the image URL that we'll use in AsyncImage to actually get the image of the Pokemon, the picture, as well as its type and description. Next, I want to actually code up the request that we're going to use. So I'm going to put this within the same file. If you want to create a new file like a Pokemon Network Manager or a Pokemon URL caller, something like that, totally up to you. But I'll just add it here. So I'll call it class Pokemon model. And I'll give it a function called get Pokemon. So this function is going to run as soon as our app loads. And this is where we're going to start to introduce some new things with Swift 5.5. So we're going to use async throws, and we're going to return an array of Pokemon. So previously, if you have any experience working with iOS development, we didn't have async and await before. There was a lot of completion handlers because when you make the network call, it's not necessarily going to finish immediately. So what should the system be doing while it's waiting for that to load? Async and await now is a more explicit way to indicate that we are waiting for a response from a server. So what we're going to do here is set up. It's similar to the previous way of doing networking. You still need to get your URL, you still make a request, you still deal with your data, just now it's a little cleaner and more direct. So we'll first say guardlet our URL equals a URL, and we'll use the string. And like I mentioned, we have that string from before. So I have it, just copy and paste it in there. And I'll be sure to leave it in the description so you can just grab it and not have to type everything out. Else, I marked this as a throwing function, so it can throw an error. So we'll create our own kind of custom errors. So we'll call it fetch error. This will be an enum, and we'll call this error a bad URL. So above the class, you can create your enum, fetch error of type error. And we have our first case, bad URL. Okay. And we'll keep adding to that as we continue to go through here. The next thing we want to do is create our request. So URL request equals URL request from URL we just made. And now this is where it's a little new from how we've done it in the past. So now we can use a tuple for data and response, and we're going to wait the results of URL session .shared.data, and we'll have this for delegate method. So for URL request, and that's it. That's letting our code know that we're waiting for this to execute and to get data back. Now you might get an error. So data for delegates only available in iOS 15 or newer. That's okay. If you get that, come over here to the settings for your project. And you can see right in the center, there's this iOS 14. So simply click on that, bring it up to iOS 15. You can come back to your Pokemon model. If you hit Command B to build, that error will go away. We're still getting an error because we're not returning anything yet, but we're getting there. We're almost ready. So now that we have a data and response, let's check what that response was. So guard response, we'll cast it as an HTTP URL response, and we're looking for the status code. Now, status codes, if you're familiar with networking, we're looking for the status code of 200. This is the code that basically says everything's good, we're ready, we can continue working. So else, we'll throw another error, we'll say fetch error, and we'll call this one, let's call this bad response. And we just add it here, case bad response, and there we go. Next, we're going to check our data. So we can say data. Before we do that, there's one method that I want to introduce, because if we go back to our network call, if we look at paw, you can see we have a whole bunch of indexes that have a lot of items in them, but this first index is null. So null doesn't really exist in Swift. We have nil. So what we want to do is deal with this first case. So let's go back, and we're going to create a custom extension on data so that we can actually remove that null value, just make it blank and kind of ignore it during the call. So if we do extension data, we'll do a func remove nulls. Yeah, we can just call it, let's say remove nulls from string, and we'll say string, and it'll return back data. If there is a null there, just remove it, otherwise keep the data we have. So we'll have let data as string, we'll convert it to strings so we can parse through it and see if we're getting that null. Say data self, encoding, we'll use UTF-8. Let's use parse data string equals data as string. And here's where we're going to replace the occurrences of string. So what we're going to pass in with just a blank. And now we'll actually check that we have some data. So guard let data equals parsed data string dot data using UTF-8, else return nil, and finally return the data. So we'll implement this now, and you'll be able to see that we're going to pass in a specific string. We want to have that removed from our call, and once we do that, return the remaining data that works. So let's do guard let data equals data dot remove nulls from string, and the string is this null question mark, else we're going to throw a fetch error, and we'll call this one bad data. So we'll have case bad data. And we can actually move this down below the response. So now we know that we have a good response. We know that we're going to have good data. Now let's do it. Let's actually get some Pokemon data back. So let maybe Pokemon data equals try our JSON decoder dot decode, and we are going to decode it into an array of Pokemon from the data that we just got back from the network call. And finally, return the Pokemon data. So if we build this, this should all now be running as expected. and we can actually start building this out and start getting some data back in our simulator. So let's go over to ContentView. Let's remove this default, and we'll do a navigation view, and we'll do a list of Pokemon. And for the individual items, we'll call it Poke. And now let's introduce some of the properties to actually get our Pokemon. So var PokemonModel, that's going to be our Pokemon model. And we will use a state property to actually update the state on this view for when we get Pokemon. So this will be an empty array of Pokemon to start, but we'll update that when the view appears. So the way we can do that, here on navigation view, we can do on appear, and we'll do, since we marked this as an async function, we need to put it within an async call. So async will set Pokemon equal to the result of our Pokemon model getting Pokemon. So get Pokemon. And now the results from get Pokemon, all the Pokemon we get from our API call, are going to be set to the Pokemon on this view, which will update once it actually changes. So let's also give this a title while we're here. Navigation title, let's call it Pokemon. And if you hit Option and Command and then P, you can get the shortcut for making the preview resume. And let's start building out our list. So we have our list of Pokemon. Just to get a quick test, let's do a text of poke.name, see if things are working as we expect. So here we go. We are getting the list of names. The title is wrong, so this might be move that one level up. There we go. So now we're actually getting the Pokemon title, and we're getting a list of all the Pokemon from our API call. So this is looking good. We're making progress. So let's start filling this out to more look like the design that I showed in the beginning. So what we're going to do within list, we'll remove this from now, we'll do an H stack, a V stack, and in this V stack, we're going to do the name of the Pokemon, their type, as well as part of the description. So we'll do text, poke.name, we'll do text, poke.type, and we will do poke.description. And now you can see we're starting to get more of our information coming in. Doesn't look great. So let's start updating and making this look a little better. So we can add some modifiers. The first one I'll do is on the V stack. We will set an alignment, and we'll make that leading. And we'll add some spacing, maybe 5, kind of separate it out a little bit. Now let's start styling up the content. So we'll give this a font of title, make the name stand out. Let's also make this capitalized. So you just add dot capitalized. Next, we can do on the type, let's make that italic. We'll also make that capitalized. I think that looks a little better. And then on the description, I don't want to show the entire description, so I'm going to give it a line limit. But first, let's make the font smaller. So we'll do caption and a line limit. I'm just going to give it 2 lines. I think that looks better. It doesn't take up as much space, especially once we start adding in the pictures. So this preview seems to have gotten stuck. So let's run it. There we go. Okay. So now you can kind of see that it is working and it's starting to look a little bit more like what I showed in the beginning, but now we need to get the picture in there. So what we're going to do is I'm going to add outside of this V stack, but still in the H stack because I want the picture to be in line with all that other content. I'm going to use AsyncImage. Now this is something new that was introduced in SwiftUI 3, and it's pretty simple to work with. So simply put in AsyncImage, and the basic implementation of it is you just give it a URL. So if we do URL, we're going to construct a URL from string poke.imageURL. And now when this runs, you can actually see it's not styled very well, but we are actually getting images populating in our simulator. So it is loading the images, it is finding them. A better way to work with AsyncImage I've found is to actually use what they call phases. So you have multiple phases, you have an empty phase, you have a successful phase, so when you actually get an image, there's also a failure phase. And since this is still new, there could be unknown cases in the future. So you just use an unknown default. So I'll show you how to do that implementation now. So we start with what we have, and now we'll do phase in, and now we'll go through a switch. So switch on phase, and we'll go through the different cases. So like I mentioned, empty, we'll just use the progress view. So this comes with SwiftUI, a view that shows the progress towards completion of a task. So basically this is just going to spin. So we can use that. Progress view, we'll do a success case. And this is when we actually get back an image. So we'll say let image. And here's where we're going to do some styling on our image. So we can do image dot resizable dot interpolation. I don't want that to be capital. Let's make that lowercase. Dot none. And then we can do scaled to fit. And lastly, I'm going to give it a frame of 100 by 100. So width and height 100. So it doesn't take up that entire view like it was doing before. And now, so switch must be exhaustive. Let's go case failure. We're not going to specify anything for that, so we'll just say image. We'll just give it a system name, and we'll use the photo. If you don't know these system names, these come from SF Symbols, so be sure you download that app and you can see a bunch of different photos that Apple gives us built in. And finally, since this is new, let's use unknown default, and we'll just say empty view. And this is another view that's built in with SwiftUI 3. So if you click on this, if you hold your option button and then you click, you can get kind of this quick preview from Xcode, kind of a quick documentation. You see a view that doesn't contain any content. So there we go. Now that we have the simulator running, you can actually see it's looking pretty good, right? So now we have our images actually loading. We're actually seeing content get populated from our network request. Now, the last thing I want to do on the styling part is, if you remember back to when I first demoed this app, you can see we have this little circle that has a different color that represents what the type of the Pokemon is. So let's go ahead and create that. That's going to be a computed property on Pokemon that's just going to look at its type and then give it a color. So let's go do it. So if we're back in PokemonModel, I'm going to have this in the description so that you can copy and paste. I don't think you want to watch me type all this out. So right here in Pokemon, beneath the coding keys, we're not going to add this as a coding key because this is a property that we're creating, but this is what a computed property looks like. So we're declaring it as our type color. It is of type color, and we are going to do a switch on type. So that we're getting back from the response. So that was the poison, normal, water, all those. And we're just giving it different colors based on what the type is. So for fire, we'll get a red color. For poison, we'll get a green, so on and so forth. And now we can use this over in our content view to actually display that little circle. So let's go ahead and do that. So back in content view, we're going to go back up into our H stack and within the V stack, and I want to put this next to the type. So I'm actually going to embed this text within its own H stack. So if you hold down the command button and you click, you get all of these different options on views within SwiftUI. So I'm going to hit this embed in H stack. If you come back out, we can now see that I have text, and I'm just going to make a circle. So circle, and then we'll do foreground color, and this is Poke.typeColor. See, just like we wrote. And then lastly, I don't want this to be huge, so let's give it a width and height of just 10. So if we resume our preview, you can now see, there we go. We have got our color of their type showing up. Looks pretty good, but there are some issues that we still have. So as you can see, as we're scrolling through, pictures will, occasionally load, some don't seem to load, and then you can kind of run back through them, and things that were loading just aren't working too well. I think this is just kind of a bug, being this is new software. This is new features for SwiftUI 3. So I want to show you an alternative method that you can use with something called Kingfisher that will make this a little smoother. It has kind of its own built-in caching system to make images just look better when they come from a network call. They don't have to be reloaded all the time. So let's go ahead and go up to File, Swift Packages. Now, if you're on the beta and you're having this problem, typically when you're on Swift Packages, there should be something that says Add Package Dependency. If you're not seeing that like me, there is another way you can do it. Simply go into your project file here, be on Targets, and down here in Frameworks, Libraries, and Embedded Content, you can actually add it manually. So when we hit the add, we'll come here to this add other and add package dependency. So here you can see I've already used this package before, so it knows, but if you don't, you can simply search for it on the URL, or here in this search field, you can search Kingfisher. You can also use the URL, which I will be sure to leave in the description. But once you have that, you want to use up to the next major version, and we're adding it to the Pokedex project. So hit add package. So it's going to fetch this and actually make sure you can add it to your project. So select Kingfisher, that's what you want to add, and you want to add it to your Pokedex target. Hit add package, and you should now see this Swift package dependency on the left. So now back in our content view, we are going to import Kingfisher, and instead of using this AsyncImage, we are going to replace this with a KFImage. So either remove this or comment it out, completely up to you. I'll just cut it out for now, and then you'll do KFImage, and you can see it just takes in a URL. So we have a URL. We'll construct our URL similarly to how we did it for AsyncImage. So we have poke.imageURL, and we'll have kind of the same things that we had before. So interpolation, make it resizable, and give it the frame width and height of 100. So if we go ahead and run this, this will rebuild, so it's taking a little time because I had to import the package. But now we'll jump over and we can see now this is loading, and now it's bringing in all of our images. And you can see it's a little faster than AsyncImage. So we're loading things in, we're not skipping a lot. So as far as a user experience goes, that's better for your users. And then when you scroll back up, it has its own caching system to where it now makes scrolling super smooth, all the pictures coming from memory. And you didn't have to do any of the code for that. This is handled automatically from that package. So one thing I do want to fix, you can see some of the layout, it's getting a little funky. It's not always off to the side where you'd want it to be. So simply to fix that within our H stack here, we're just going to add a spacer. So that's going to push all of our elements to the side. So now we have our images consistently on the side, as well as the rest of the information about the Pokemon on the leading side. So now you can see scrolling through a lot more consistent. Well, that's it, everybody. Thank you so much for watching. I appreciate it. If you enjoyed the video, please be sure to leave it a like and consider subscribing. I put out videos every week. Thanks, everybody. Catch you in the next one.